Hello, hello, hello. We are going to kick off our main presentation tonight. The topic is Meshtastic. And what I have here are two Meshtastic nodes. They're marvelously capable, interesting devices. As an overview, your phone hooks up to this thing through Bluetooth. This thing hooks up to any other node and creates a mesh. So you're basically doing text from your phone to this device with no cell phones required, no internet required. It's really a remarkable business. Andy has been a local heavyweight in setting up the mesh. I'm a student of his. I follow his work. He's terribly talented, incredibly generous with his time, and I got into this largely because Andy got into it first. So thank you, Andy, for coming, straighten us out, and tell us what is what. The floor is yours.
Okay, thank you, Don. I'm Andy, K1RA, XKA1GD, and XWB1ALW. Was licensed back in 1976 in the state of Connecticut. Moved down here to the DC area in 1980. My dad took a job at the Voice of America. Attended the University of Maryland. That's W3 Echo Alpha X-ray for those following college stations. Got my double E degree, and I've had a career in systems engineering, electronic hardware, computer software, networking, security, and recently consulting in the 4G LTE telecom arena. I'm a member of the regional club, Potomac Valley Radio Club, PVRC, and my local county club, Fauquier Amateur Radio Association, that's W4 Victor Alpha. And actually, although I enjoy playing with mesh over the last year or two, the facets of the hobby that I've enjoyed the most over my ham career has been the radio sport contesting aspect of the hobby, starting out in HF contesting and then going into VHF, UHF microwave. And any of those of you who are DXers, operate CW, use any of the DX clusters, reverse beacon network. I run a multi-band, multi-mode skimmer system. Okay, so I will point out that I will make this presentation available to anyone who would like to look at it afterwards. You'll notice that there's some blue URL clickable links embedded in this presentation, like my email addresses and or resources. So feel free to ask me at K1RA at K1RA.us or AndyZ at AndyZ.us. Okay, so quick presentation overview. I'll talk a little bit about what is LoRa. Again, this is a presentation that's an intro, so I'm not going to do a deep dive really on many of the topic areas that we could do. I'll talk a little bit about what does LoRa signal look like, define the Meshtastic hardware and software that's available today, look at some off-the-shelf LoRa radios that you can get pretty easily at 3 or 4 vendors. You can get them off Amazon, relatively inexpensive. I'll talk a little bit about why use Meshtastic. We'll talk a little bit about networking details, what makes the mesh. Talk a little bit about the specific Northern Virginia mesh as it stands today. A little bit different than what comes default out of the box. Talk a little bit about how to configure and program the radio and its usage, as Don alluded to earlier, how to use Bluetooth and the like to interact with the radio. And then we're going to set some expectations and talk about some real world lessons learned over the past couple of years that we've been doing this. And then, as I said, in conclusion, and some online resources that maybe you'd like to look at if you're interested in this. Okay, so what is LoRa? It stands for long range radio. It's designed for low power networking, and we're talking low power in the hundreds of milliwatts. So most hams probably have an HT that runs 5 watts or 5,000 milliwatts. So we're talking under 1,000 milliwatts, under a watt, geared towards the IoT or Internet of Things community, which has been out there for now a good number of years. It's an unlicensed technology as it's used today, and as I'm speaking about it tonight, it exists in the 433 megahertz band here in the US and in Europe. Europe also has the 860 meg band, where there's a number of nodes that are active. But most of the activity we're going to talk about here tonight is in the 900 megahertz or 33 centimeter band, which hams do have access to as a licensed band, where we can use up to 1,500 watts of power. But we're going to talk about the free band ISM aspect of it. from pretty large bandwidths, 30 kilohertz, all the way up to 500 kilohertz or a half a megahertz wide. Most of us are using 3 kilohertz on sideband, 5 kilohertz on FM maybe. So these are very wide mode signals. It is wireless. It's an encoded system which is equated to chirp spread spectrum, similar to how dolphins, maybe bats communicate. And if you can listen to it or see it, it's got the same kind of frequency analysis. If you're familiar with the FT8 mode that a lot of hams have been using on HF over the past number of years, LoRa is somewhat similar in these ways. It can decode what we call below the noise floor, depending on how you configure the radio, spreading factor, et cetera. Because of that, it tends to be more robust against interference, our normal 3, 4, 5G technologies. And where did it come from? It was actually developed in France. The technology was later acquired by a company called Semtech that's out in California, which are producing the chips or the radio modules that are used on these nodes. But it is a closed source technology. The hardware is closed source. Doesn't mean people haven't reverse engineered it, but it is it's not in the public domain. Okay, so a quick look at what is this chirp spread spectrum type signal look like. On the left-hand side here, you'll see along the x-axis, the horizontal axis, you'll see frequency, and along the vertical axis, we're looking at time. So when data is encoded in this LoRa technology, you sweep from low to high or high to low, and the rate at which you sweep is the spreading factor, and that can be seen on the right-hand side of the page. This can affect how fast or how slow a transmission takes based on your sweeping or the spread factor. There's a great YouTube video on this that goes into detail, has some video that actually looks at these types of signals and how they act at different rates. I want to click on that at the bottom. Many of us have software-defined radios. This is my AirSpy SDR looking at 904 megahertz band, and just grabbing a very small snapshot of what a LoRa transmission might look like. So on the bottom, typical waterfall display. So most recent signal is at the top of the waterfall, and as you go further down the waterfall, that's back in time, historic data. And the top is your standard real-time spectrum display. So most transmissions happen so fast that you don't see the sweeping in the waterfall, like I showed on the previous page. And it just looks like one big blob. And again, you can see we're at 904.1 megahertz, and we go up to about 904.4 megahertz, using about 250 kilohertz of bandwidth to encode this one text message that I sent and captured. Okay. So that's kind of the hardware aspect. As I said, not going to go into any great detail on what LoRa is. Really want to talk about Meshtastic, which is an application that is written to ride on top of this modulation scheme called LoRa. Meshtastic is open source. Again, it's considered a mesh or off-grid decentralized network. It's definitely built on low-cost, cheap, affordable radios. But again, these radios are low power. Okay, so let's talk about Meshtastic. Again, as I mentioned, it's a digital texting app. It's firmware that runs on top of or in conjunction with these Semtech radio modules. Now, when we talk about firmware, you need some sort of processor to run firmware. So again, the radio module is kind of like your HT, right? It's what makes FM or the LoRa protocol. The firmware that we're talking about, the Meshtastic, runs on either ESP32 processors made by SBRIF or the NRF52 made by RAC. Those are the two most common out there. You can find stuff working on Raspberry Pi, but most of these cheap nodes I'll talk about run on one of these two very low-end processors. Again, for the discussion here, we're talking about radios that use the 902 to 928 megahertz spectrum, running about 250 milliwatts at most. And again, bandwidths vary depending on how you configure the radio. We'll get into that in a little bit. Back to the Meshtastic software, two pieces of it. Again, there's the piece that runs on the node, on that SBRIF or RAC processor. And then there's a piece that runs on your phone. The radio itself, most of these low-cost radios have no keyboard, have no LCD screen or display. They're just a little double postage stamp size board that you can pop an antenna on, plug a USB cable in, and power it up. So at a minimum, you need some sort of way to talk to it. As alluded to earlier, Bluetooth is the most common way to connect to the node. So you either need a smartphone, an iOS, or an Android device. There is a web user interface that you can get to if you want to configure your node to get or run on Wi-Fi. And for those of you who use PCs, the gamers use something called BlueStack. It's actually an Android emulator, so anything that you can get out of the Google Play Store, you can actually run on your PC. Same thing with the Meshtastic app. So numerous ways that you can talk to your node. We'll call this the client piece that talks to the server radio piece. Again, Bluetooth, Wi-Fi, and there is a serial USB connection as well. We're looking at data rates on the very low end, like RTTY, for those of you who've ever run low bandwidth ready, like 90 bits per second, all the way up to about 40 kilobits per second. So if we're looking at characters per second, 10 characters per second on the low side to about 4,500 characters per second at the fastest rate that these radios will run. So we're not talking about moving video. You're not going to be streaming with these things. There's a chance that you can move audio through this, but it's really meant for texting. It does implement an encrypted mesh network. So in the configuration that most all of us are running here in Northern Virginia, we're running this in the free band mode, so anybody can get on with these radios and talk to each other. But because they're running an encrypted, you cannot run as a ham anything more than the 250 milliwatts. There is a ham mode. I'll talk a little bit about that in a bit. But we're running for the masses, so encrypted and low power. Every node acts as a relay or a repeater. That's how you build and extend the mesh. It does not rely on the cellular network or the internet, but it can leverage the internet. I'll talk about that in a little bit, why you might want to do that. And for all of you software dev guys, there's an API and there's some command line access for programmatic interactions and control. Personally, I write some Python code to talk to my node to do some automatic things that I'll present later. Okay, so some Meshtastic definitions. Now, most of you people here are radio guys, so you're going to notice some things that are not quite standard. I like to think that these guys, these software Meshtastic guys, have no radio background for some of the technology, that some of the terms that they use. But anyway, again, Meshtastic, it's a message-based protocol running over the LoRa modulation scheme. Mesh, a group of nodes that communicate and relay data packets amongst each other. A node is a LoRa transmitter receiver with the mesh firmware loaded on it and some sort of app at least to configure it. Once it's configured, it can actually run standalone, and you do not need a phone or a PC to talk to it anymore. It can simply be a relay node from that point forward. There is these things called presets. So, and again, that gets back to the modulation scheme of LoRa. Just like we have upper sideband and lower sideband, and you can adjust the bandwidth of your radio for narrow if you're operating CW or wide if you're using AM. Well, there are different types of presets for the LoRa modulation scheme that control or affect the range of your communications, the speed at which your communications take place, the spread, which I alluded to earlier in kind of that chirp picture I showed, and of course the bandwidth. We're talking a 30 kilohertz bandwidth on the low end or 500 kilohertz on the high end. Every node is configured as a certain type of role. A majority of all of you, or most of you who ever get a node, you're going to probably run in client if you have one node. If you have more than one node, we say have one node client, everybody else client mute. I'll talk about that later. And then there's roles of router and router late, which we'll not talk about in any depth. But in any case, any one of those roles are both a client, can participate in texting and receiving messages, and they are relays for repeaters, except for client mute. Again, a weird term. You would think otherwise. Okay, here's one that gets me. A slot. A slot is really a frequency. We're all hams. We talk about megahertz, 2 meters, 144 megahertz, 70 centimeters, 440 megahertz. Meshtastic uses slots, and there's actually a slot calculator, which can tell you, based on the slot number that you program your radio, what frequency it shows up on. but they don't talk frequency when they talk about configuration. The concept of a hop, it's just how many times a packet has been relayed or how many repeaters it's gone through. Another kind of confusing term, if you're a ham, they talk about channels. And I can equate this more to like a chat room or a chat group or a talk group. It's not a channel like CB where, you're on channel 19 and it's on 27 megahertz somewhere in the band. So don't get channel confused with frequency. PSK, there's a pre-shared key. Again, Meshtastic is encrypted. So just like your Wi-Fi router has an encrypted PSK, so only you and your family can connect up to the internet through it. There is a PSK set per channel, per talk group, and you can, by default, use the main PSK that all nodes come with, and that allows everybody to talk to everybody. But other people can create other channels and set up their own pre-shared keys, and they can communicate using encryption over the entire mesh network, even though intermediate nodes may not have that PSK. And then there's device metrics, which are node health, location, telemetry, SNR, number of hops, data that's carried in the packet as it traverses the network, and you can see that in the app. Okay, so let's look a little bit at some opportunities to get some cheap radios. So on the low end, Heltec V3 on the left, little LCD display, USB-C connector, little Wi-Fi antenna for Wi-Fi Bluetooth, a couple of test buttons to do a reset and interact with the display, little IPEX connector on the right-hand side where you can connect up an SMA or an N connector and connect an outdoor antenna. The bottom is the ESP32 chip, also a connection for a battery. If you want to put this in say a solar node potentially. $25 maybe on Amazon, $15, $20 on AliExpress. LilyGo, no GPS, so it's just basically a radio with a screen and the ability to talk to your phone. LilyGo, about the same, no GPS, has an SMA connector. That's kind of nice. Those IPEX connectors are a little bit difficult to deal with on the other node. But same Bluetooth, Wi-Fi capability, a little LCD display, radio module, and the ESPF are mounted on the bottom side of the board there on the bottom. And then we look on the right hand of the screen, the LilyGo T-Beam. This has how it differs from the other, same Bluetooth, Wi-Fi. Has an optional display if you want to solder it in. Sometimes people sell it with it. Has an SMA connector, comes with GPS. A lot of people tend to use the T-Beam going mobile. You have an 18650 lithium ion battery cell compartment on the bottom that you can plug a battery in and go. I can go for maybe 12 to 18 hours, depending on how much activity is on the mesh, or I have to recharge it. Okay, and again, those are in the $20 to $40, $50 range. It goes up from there. You get these nice self-contained units, which have e-ink displays and self-contained in a nice 3D printed box, or some of these others like the LilyGo T-Deck. They have kind of a BlackBerry feel to them, a keyboard and a larger monitor. The sky's the limit. They're putting all sorts of packaging around these little LoRa chips and ESP or RF rack CPUs. But I call it more eye candy than anything else. They all, at the basics, they all do the same thing. Same amount of power, same LoRa chip, et cetera. Bluetooth, Wi-Fi. And as mentioned earlier, even though there is a corner on the market with Semtech and rack, or SBRIF and rack, you can get a hat module, a LoRa hat for your Raspberry Pi, and load software on it and turn it into a node. And again, back to more money, you can buy off-the-shelf solar nodes that have an antenna and a solar cell array and a built-in battery and everything kind of nicely integrated. If you want to throw something up on a roof or up on a tower and set and forget. Okay, so why use Meshtastic radio equipment? A lot of reasons. Personally, for me, it was just something to experiment with. I'm kind of a UHF, VHF microwave guy, so it's a fairly inexpensive radio that does digital messaging at some higher frequencies or shorter wavelengths. I mentioned 33 centimeters, 900 megahertz. We as hams have access to that band. Very little activity on 900 meg. There's some weak signal work if you're doing CW and sideband and FT8, but it's not a worldwide band for hams, so you're not finding a lot of 900 megahertz radios out of out of Japan or China, unfortunately. So this is a way to get on that band without much expense. It's a way to analyze and look at very wide bandwidth modes. Again, most of us as hams are using very, very narrow bandwidth modulation schemes. So, what happens when you run something at 30 or 500 kilohertz wide? How does it propagate? What are some of the issues? Again, a little bit of science to play with. A lot of DIY, as we were talking about the 33 centimeter band, that wavelength is very short. So for those of us who like to build antennas, it's a very easy and small antenna to build, whether they be dipoles or Yagis, to extend local coverage. If you're a software guy, again, the Meshtastic aspect of this project is open source, so you can actually contribute to the development and extension of it. I've provided some bug fixes and requests to the developers that they have taken to heart and implemented and updated their firmware. So they're pretty open when it comes to that. The big thing for me as a part of the FARA Club, W4VA, where the Nova Mesh really grew out of, it's a way to involve non-hams in radio frequency experimentation in our hobby, which is, it is radio, it is wireless. I find through Meshtastic that there are a number of very well-educated, smart, younger folks who are into computer hardware and computer software, and they know Wi-Fi, but they don't know RF. Yet this Meshtastic project has taken off in the world, and they're playing with it. They're asking questions, but they don't really know the science behind radio. So when Don alluded to earlier, I have been giving my time and decades on the air, but to some of these people to say, hey, there's propagation effects, there's tropospheric effects, there's interference problems, and the like. So in a lot of ways, if they start to glom onto that, this can really be a gateway technology to get them into ham radio, because 33 centimeters, 900 megahertz. For any of you on 70 centimeters, 400 megahertz, you know how propagation is, right? Line of sight, not very far. 900 megahertz can be even shorter distance of coverage. So after a while, a lot of these guys are going, they get into Meshtastic thinking they're going to talk to the world, talk across the US, and the reality is not. So again, hey, there's ham if you want to go to a different band. And finally, again, learning to program, again, a lot of Python apps out there and free source code to interact with the radios. So I've taken some of that and built some cool things. Okay, a little bit about networking details. We're not going to go into great depths on all the different configuration screens and the like for getting your radio up and running, but we'll just talk to some of the highlights. There is a user config. You got to give your user node a name. There's a long name and a short name. There's an amateur radio mode when you config a user, so there's kind of like a yes/no. If you configure for ham mode, it turns encryption off, and it allows you to run a little bit more power out of the radio. Of course, you can always put an amplifier on the radio and run even more power, but amateur radio mode means no encryption. Again, there's a role. Again, you're either going to be client or client mute. Again, client, you are an endpoint, text to send and receive, and a relay. Client mute, you can only send and receive messages. You don't relay anything that you hear, hence the mute point. There's a channel. Again, that's the chat group by default. There's a standard preset name, so you don't have to guess with your neighbors what it is. If you all agree to a certain basic config, you get one chat group out of the gate. Then there's position config. Again, some of these nodes have GPS, so you can advertise kind of like APRS, a lat long. Let's see where you are. Otherwise, you can program your node with a fixed location if it's sitting on a tower or house. Here's some screenshots below, kind of what that looks like. There's some timing intervals on how often messages are set, but this is basically the Bluetooth, this is the Android UI, user interface on your Android phone into the Meshtastic app. We're setting up some options. Okay, let's talk a little bit about the Meshtastic networking details, the nitty gritty of like LoRa. Again, I'm not going to go into great detail. I'll point out some highlights here, but earlier I talked about these modulation presets. They use some pretty interesting names like short turbo or short fast or medium slow or long fast or very long slow. The first word usually represents the range of coverage, and the second word is some indication of the speed of your transmission. So we'll take a look at short turbo at the top. You're looking at 21 kilobits per second. speed. And in blue, note there's a link budget. You need 140 dB of link budget to make a path. If any of you know about issues with 70 centimeters in foliage, you can attenuate the signal. It gets to be even worse as you get higher in frequency. I'm not going to go into link budgets, but I'll point out that let's look at very long slow. Only sends 90 bits per second, or 0.09 kilobits per second. But look at the link budget that you have. You have 161.5 dB link budget. That's 21.5 dB better than the short turbo mode. What does that mean? Roughly, without getting into the physics, every 6 dB you can maybe double your coverage. So if you look at how many 6 dBs are in 21, you're looking at 3 or 4 times the coverage expansion area when you're looking at the difference between the modes. So I highlight long fast because that's where all default radios end up as a preset. There's the hop count by default. That's set to 3. We happen to be running something slightly different. On ours, we're running a hop limit of 5. Again, the slot dictates the carrier frequency. So you can see the short and long have 104 slots because they're fairly wide bandwidth. The very long slow has narrower bandwidth, so you get more slots. And then there's a payload, like any network packet. There's a header, has your addressing, has a message number, has some ACK/NAC and some encryption-related data. And then there's about 200 bytes left for whatever message telemetry that you'd like to package. Again, on the right-hand side of the screen is another app view, the Meshtastic app, or what we call the LoRa config, the modem preset, the hop count, the slot. And I'm highlighting these that we use a hop count of 5, which is slightly different from the default, and a frequency slot of 9. By default, they use 0. I'll talk a little bit about that later. So signal identification, again, back to the naming convention, long, slow. If you use your SDR, it's actually so slow you can almost see the sweeping of the carrier back and forth as it's encoding the data in the upper left, and then in the lower right, short, fast, kind of looks like what I showed you earlier on my SDR. You just get these blips. That 200 bytes is a couple hundred milliseconds, if that, over the air. There's a great YouTube video where a guy goes into great depths and he plays all of these, and you can hear them and see them in motion. But grab the screenshots to show you here the different the bit rates and the spread factor and the bandwidths associated with each. Okay, so let's get into Nova, where we all live and love the area. There's a pretty good community out there now over the past couple of years, and we've shared through Groups.io, which I'll provide the link later, and Signal for some kind of real-time messaging and testing. A bunch of guys, both hams and non-hams, who've shared pictures over the years of their setups. Many of you may know David, KK4ZUU. On the left there, he's running an outdoor 900 megahertz panel antenna that he was experimenting with on the side of his house. And then in his attic, he was playing with an Omni, short 3-foot stick, and had a nice little kind of waterproof container with a node and a power that came out the bottom. He was using power over Ethernet up into his attic and playing with 2 different nodes. On the right, somebody building what we saw earlier, you can buy off the shelf now. It's kind of a solar node, a couple of 18650 lithium-ion cells and a battery holder, the node up at the top, a little SMA connector in the top left, and the GPS connector glued to the top. So you can get the external antenna for the node, 900 meg, and there's a solar cell on the other side for charging. On the left, somebody found that, hey, all those old cells that come out of batteries that, you get a dead battery out of a laptop. Usually one of the 2 cells goes bad and the third and fourth ones may be good. They're all about 3.3 to 4 volt cells, perfect for powering nodes. Some of these cells are thousands of milliamp hours, and these nodes are very low power, so you can run quite a long period of time. You want to adapt a battery to the nodes. Let's see, was this VWS? This might have been done. I don't know. Somebody shared a couple of pictures, a pill bottle container holding a node with an Omni antenna zip tied to it and a solar cell. Somebody building and or acquiring a PCB dipole on the right, connected to an SMA connector and cable that goes back to the node. Again, some interesting DIY, trying to get up the node nice and high on a stick in the air. KK4UYX, he's a member of the FARA Club. He's been instrumental in handing out nodes, acquiring nodes, putting nodes in high locations. He and I worked in town here at the courthouse. I'll point out two things that I'll get into more later. On the left, we have our antenna, 5 dBi gain antenna. You see in the distance a water tower. Remember that water tower. And then on the right, I will have you look at the horizon. You can see for miles. Height is everything at UHF and microwave frequencies. Here's a picture of an antenna from top of my dad's 65-foot tower. I put a node out at his place in Amosville. I live here in Warrenton. This antenna, a loop, what's called a loop Yagi, pointing back towards Warrenton about 12 miles away, is able to reach into that UYX node that I showed you earlier to make the path. So a little bit of gain and a little bit of height can do some pretty good distances. A node I was playing with, marrying it with a Raspberry Pi. One of the unfortunate aspects of Meshtastic is there's no over-the-air updates. So if you need to update your firmware and it's up on a tower, you got to climb the tower and pull it down. You have to plug a USB cable in to push the firmware onto it. You can't push it over Wi-Fi, you can't push it over Bluetooth. So my trick was to marry it with a Raspberry Pi that does have Wi-Fi, so I can push it out the serial port, and hence something that I'm looking to put in a box on my dad's tower. This is my node, just again, a similar 5 dB stick antenna sitting outside my window, some LMR 240 coax. In the node, not even in a box, just laying up against the window, looking at the second story node of second story of my house. We've got a fellow here in Northern Virginia. For those of you who follow instructables.com, a great website where you can teach people how to build things. He found some solar buoys on AliExpress and thought, boy, wouldn't these be great to stick a node in and power them up and stick them up in a tree? You don't have to float them in the water. Stick a little antenna on top, tie a string to them. So look at this link, instructables.com, for the Meshtastic solar buoy. There's one running out in West Leesburg that's providing us some very good coverage. He made a slight modification to a second solar buoy he made to allow him to put a much larger stick antenna, higher gain that you see there, the white stick on the left. His node is WLEE, that's the short name. Another node we call the D hex nodes or dot hex nodes. Fellow out in the Tyson's Corner area, up 10th or 20th floor in a building, putting a couple of nodes in each face of the building. You can see some pictures there on the left, and some coverage wedges on the right that allow him to extend coverage out from the Tyson area. Again, remember, height is everything. So on the very right-hand side of the screen, there's a concept of a trace route. Some of you who are internet diagnosers of connectivity might use the Windows or command line trace route. Again, I'm in Warrenton, and the Tyson's node was only 2 hops away, which is a tremendously long distance coverage for these radios. More to follow on some maps later. Again, a couple other instructables. There's a DC mesh group on Discord. They made the solar Easter egg and set it out outside at ground level. Not sure how great that is, but at least it's waterproof. Some other guys using more of the waterproof containers and sticking nodes up on chimney tops in DC. Okay, so enough pictures, show and tell. Let's talk about Nova and the specifics if you want to join our network. Talk a little bit about it. Again, the mesh grew out of FARA, the W4VA club, specifically Harv K2PI and myself back in July of 2023. Harv came to the club and basically said, hey, my wife and kids, they don't want to get their ham licenses, but we go hiking. They always carry their cell phones, but when we're out hiking, the cell phones tend to be useless because we're not near a cell tower. So wouldn't it be great if we could still text each other along the trail as we were out and about? So that was his impetus to get into Meshtastic, having some short distance communications with something everybody carries around with them, a cell phone. Myself, again, I'm a VHF, UHF, VHF microwave guy, specifically into radio sport competition aspects. I'm all about DXing, pushing the limits. FARA member David KK4UYX leads the area in deployments in our county. He has put up at least 5 or 6 nodes. So you'll see UIX3, UIX4, UIX5, and so forth and so on. He is looking to get those up at high locations, towers, ridges along various mountain ranges here in the county. Since 2023, we've had 100 unique calls, names, individuals that have participated on our mesh. That has resulted in 300 or more node names that have been recorded at my location in Warrenton from around Northern Virginia, saying that some people have had more than one node. Don, for example, some of us 2, 3, 4 nodes. So on any particular day of late, we have 100 active nodes in Northern Virginia on our mesh in the Northern Virginia slot 9. Many users have nodes, and again, this is changing almost daily now since our mesh tends to be growing as the word gets out. But kind of West Leesburg, Steve's node kind of to the north. We've got some Culpeper node to the south, the Ham K4PFE. We've got some nodes out in East Falls Church, and now reaching in, not quite Vienna yet, but I'll show a map here in a bit. We have a node out that I put out in west of Winchester at 2,300 feet. Again, height is everything. I'll talk a little bit about that term MQTT that you see there against Culpeper and Winchester. Okay, so since its inception, I've been running a mesh map. If you go to http://meshmap.k1ra.us:54321, on a little Raspberry Pi here, I'm running on my table, I run a little piece of software that collects packets, and those sending geographic lat longs, I plot on a map. And for those of us who are advertising our neighbors or our direct zero hop stations who we hear that aren't being relayed, you see the lines. Anyway, red nodes are offline, blue nodes are online, green nodes are MQTT. I'll talk about that more in a minute. Here's what our node map looks like over the last 7 days. So again, I'll point out here, we started down here in the center of the screen. That green dot is K1RA. You're right here in the center of Warrenton. Culpeper is down here to the southwest. Winchester is up here to the northwest. We have Leesburg up here to the north, the high side, and Tyson's Corner here, where you see all these lines going to, and some nodes starting to come in, McLean, and we have a Bethesda node that can reach in. We're trying to work your way east towards Vienna. Believe me, guys, we know you've been around for a while, and those who have tried have not quite made it in, but we're here to help. So there's a map that's running pretty regularly. By the way, there's a search button, so a search menu, so you can search for a node name and search to find out where they are. You can click on a dot, and it brings up information about their battery health, their signal to noise ratio, a bunch of telemetry and metrics. So it's a nice interactive map. It's more than just a visual to where people sit. Okay, so you want to get on the air. You're a first timer. What do you have to do? So high level. You're going to need a USB cable between your radio and the PC because, as I said, there's no over-the-air updates. You've got to kind of push over a serial port, the firmware. You need to know a little bit about your computer operating system. I'm a Windows-centric guy. Other than doing Linux all the time, most of you are Windows, so I'll say things like, you need to know where Device Manager is so you can find a COM port. You need to know that the COM represents a serial device and that it has a number associated with it. Hopefully you have Chrome because they now have an easier mean to push the firmware from a web browser right to your node. They have an online web flasher tool that's different from a couple of years ago when we were doing things command line, aka DOS level commands. There's even an auto detect mode, so you may not even have to know your COM port number from above, but they're making it better and easier to program nodes all the time. But you do have to pick a firmware off a web page. There's a kind of a beta stable release, and there's an alpha bleeding edge release. There's usually 4 or 5 available. If you join our group or you talk to some of the guys, we can give you the best number to run with. And essentially, you erase your node because it does come with pre-programmed firmware, and you upload the firmware, and boom, you can now unplug your serial cable, USB cable from the node, and now move on to your phone, where you have to download the Meshtastic app. You Google people, go to the Play Store. Otherwise, you go to the App Store if you're iOS. Easiest to enable Bluetooth on your phone. You can add the radio as a Bluetooth device. It'll ask you for a PIN number. You can program that from usually the LCD screen of the node. And then you go into some of the screens I showed you earlier as you got a user setting. So you got to give yourself a name. You got to set up kind of the device configs and the LoRa configs, those modem presets, and how many hops do you want to be able to communicate away, and what slot do you want to be on. And then there's a bunch of optional stuff. Do you want to create other talk groups or channels? Do you want to advertise your position, fixed or GPS? You want to adjust your Bluetooth, put it on Wi-Fi instead. You want to turn your display on and off, save battery power. Okay, so let's look a little bit about what this whole previous page looks like if you're a Windows person. Again, I make this presentation available to you offline. Just kind of follow the bouncy ball, step 1, 2, 3, 4. I kind of step you through the various screenshots and pages to help you through this. So I'm not going to spend a lot of time going into it. But again, you're opening up a browser, which you kind of see in the gray in the background, and you've got your device manager, which in this particular case I've noted down at the bottom in red. My node shows up as COM7, so it's kind of, I need to know that if I'm not going to try this auto detect mode. I need to know what type of radio I have. They made it very easy now. They have pictures of all the radios, and you kind of click the button or you click auto detect, and it hones in on your device so it knows what firmware to grab and download. And then you get a drop-down box of the stable and unstable releases. What do you want to run? You pick the radio, you're going to select your firmware, and you're going to click flash. And before it actually flashes, you can choose the baud rate. Any baud rate should work. You can do slower is usually more stable, faster, higher, it goes a little bit faster. Again, it's going to ask you to confirm, or you really want to push it to COM7 in my case. Yep, I'm doing a full erase, which erases the previous firmware, which wasn't Meshtastic that came on my node. There's a little button for that. And you hit connect, hit erase and flash at the bottom and install. And after about 60 seconds of writing, you get to about 100% completion, and you're done with programming your radio. So from start to finish, you're probably looking at, maybe 5 minutes, 10 minutes if you're unfamiliar with Device Manager. But relatively quickly now these days to get the firmware onto the radio node. Okay, unplug your cable from the PC. You can throw the PC away. You got to move to your phone. We'll talk a little bit about these first-time configurations for some settings. In our groups IO, on our Signal chat group, there's been one of our, I think, non-ham members actually, who said, hey, wouldn't it be great if I could create a QR code and a cheat sheet for the Nova Mesh? And he's done so there on the right-hand side of the page. So kind of all the little screens and places you need to go and what you need to set and what some of the options are going one mode versus another mode. But for the rest of this, again, you need a short name. They're limited to 4 characters. So for those of us with nice short vanity calls, it fits in nice and easily. We're suggesting for hams, though, if you've got a longer call, use the last 4 characters of your call sign. Helps us keep track of people. There's a lot of nodes that are on there just come with the default hex code of their node. Not really useful if you want to, try to find somebody and say, hey, your node's going squirrely, you need to turn it off, or it's a bit misconfigured. We as hams know it's easier to help people out if we know what their call signs are. And then there's the concept of the long node name as well, which can be much more verbose, like K1HTV Tower. He has one HTVT. He has a mobile one, K1HTV lowercase m, one at the house, K1HTV3. So kind of keeping that vein of naming your nodes if you're a ham. Otherwise, for non-hams, if you're a GMRS guy, use the last 3 digits of your GMRS call. We've got a bunch of GMRS guys on. Maybe use your 3-letter initials and a number. Again, something that if you're having multiple nodes, people know, oh, all those are attributed to you. Here's kind of the connection process when you connect up with the Google app after you download it from the Play Store. You're basically in this screen where you have to connect either via Bluetooth or an IP address in the center of the screen. There's a plus button at the bottom. So one way or another, it either pops up and says, hey, I found a Bluetooth device, or it's trying to connect to an IP address, which you looked at. We won't get into the details of how you find that. But you eventually have to connect. You got to make that connection between the phone and the node. And from there on in, now you got to do some basics. You got to do the radio configuration piece, which is step 5 and 6. The LoRa piece, very important. And then the device settings, very important. All that other stuff, optional. Again, kind of screenshot of the Nova Mesh, the LoRa preset, long fast by default. That's what we've been running. We're in the United States. That's our region. We're running, the default is 3 hops. We've pushed ours out to 5, cover a little bit more area since we're growing. We're running slot 9 against again, the default is 0. So I know a lot of the Vienna guys end up falling back to a slot 0. And I think they even fell back to a slower preset to get a little bit more SNR, a link budget. Instead of running long fast, they might have been running long moderate or long slow. But anyway, again, look at the earlier slides if you want to try to make a 2, 3, 4, 5 mile path, play with that modem preset. Okay to MQTT, it's important to turn that on. We actually do leverage the internet. And again, I'll still talk about that in a bit, but for our Nova Mesh, we encourage that you turn that radio button on. And then again, your device role on the right. Everybody really should be client. If you have more than one node, make one client and the other's client mute. You only need one relay at your house, right? You don't need multiple repeaters. You'll just be creating a bunch of interference amongst your local nodes, and you'll never get very far because all your hop counts will be decremented as they're hopping through your house. Again, once you get through that major setup, you're pretty much on the air. There's a couple of icons along the middle of the screen here that first of all, the check cloud in the upper left. That's an indication that the app is connected to the node. If you see a cloud slash, you're not talking to your node. It's disconnected via Bluetooth or Wi-Fi, so you've got to remedy that. But then there's the menu bar below it, specifically left to right. There's kind of like a nodes list, a map list, a configuration list. Again, different screens that allow you different views into the mesh network. You can see in the middle of the screen the short node names and the colored ovals. You see the longer node names next to that, what type of node they're running, a Heltec, a T-Beam, if they're advertising a lat LAN, if you've got a lat LAN, how far away they are, and how many hops away they are, what their elevation is, et cetera. And then, of course, there's a built-in map, which is kind of nice. So you're on the air. You can basically do direct messages, or you can talk in your long chat group. As I said, there's this version of tracing, so you can see how many nodes away you are. Everybody pretty much on Nova Mesh uses the long, fast chat group. There's some people doing direct messaging, but in general, we're a community. We're just passing messages back and forth, doing tests, et cetera. So let's set some expectations and caveats. The mesh is only as effective as when nodes stay on the air and powered on. Height and altitude is everything. Again, these are UHF approaching microwave frequencies, so they're line of sight, but remember from your technician test that line of sight is really 1/3 past your visual horizon. Outside, high gain antennas are needed to greatly extend coverage. So if you're using this little 2-inch rubber duck that comes with your node and you're operating in your house, don't expect to work across town. 33 centimeters, more affected by foliage and attenuation in structures and terrain than their 70 centimeter band. Interference issues, the 900 meg band is considered an ISM band. A lot of service medical equipment, we call it the armpit of the RF spectrum, all sorts of stuff there. It turns out that even a lot of the toll road equipment on 66 is running on 900 megs. So you can be at the mercy of a lot of it, local interference, and not know it if you don't have an SDR. You as ham should probably look at the band to see if you're suffering that. Again, remember that dB computation and how that affects range or coverage. Data passing is best effort. It's a lot like internet UDP. There's no acknowledgement. Unless you're doing direct messaging, all group chat is just send and forget. It's open source. It's done at the developer's leisure time, so take that as it is. There are frequent updates and bug fixes, so that can lead to a lot of reflashing. Much of the reflashing has to do with supporting new hardware, so there's not a lot of bug fixes. There's some new features, but anyhow. Big problem that I see is Android, iOS, web apps. The user interfaces differ substantially. So because of that, if you're an iOS guy and you're trying to work with an Android guy and help them get them online, not all the screens are the same. So be aware of that. I do long distance DXing, so I use like Ubiquity tools and some other range tools that plot terrain. Here's some of our longest DX on 900 megahertz, 44 kilometers from Lorton to Warrenton. One hop, just A to B, point to point. You can see because of the terrain in the Fresnel zone there at the bottom that, it's not a reliable path, but there is a path there. We have a bunch of nodes up on Bull Run Mountain outside the Beltway, just west of Route 15 that goes up through Haymarket. 1,000 feet there, you can see the node on the left, the blue dot, and one down in the Manassas area. Again, completely free Fresnel zone. very solid path, very reliable all the time at our rate. DirectiveSystems.com, made in America, made in Virginia. If you're looking for 50 megahertz and above antennas, all the way up through 10 gigahertz, husband-wife team who I know well, making antennas handmade and in kit form. So check them out, DirectiveSystems.com. I alluded to earlier one on my dad's tower. Some other paths, this tool here shows that, hey, this path probably isn't actually even usable from a line of sight perspective. My dad's house out in Amosville, 21 kilometers away from Warrenton. This path has actually been made. And again, we attribute this to the LoRa protocol being able to hear into the noise more efficient than, say, AM, FM, or even CW. So we're kind of surprised at some of the paths that we get. SDRs, as I said, are your friend. It helps to visualize the band. Here I'm looking at a 60 megahertz swath right in the middle. The line is 900 megahertz. I'm pointing out where our mesh transmission is there in yellow. You can see a burst of information. Interference to the south, to the left, cell tower. So if you live near a cell tower, your radio could be easily overloaded. You may need a bandpass filter. If you're running other data modems in your house on 900 megahertz, they could be over saturating your little nodes receivers. Remember, these nodes are cheap. They're cheap for a reason. They're not selective. They're not like your ICOM and Yaesu rigs that have bandpass filtering for every band and mode that you tune to. So these little radios may need a little bit of help. This slide really here talks about a very loud cell tower that I pointed out earlier on the water tower. It was extremely loud, 70 dB above the noise floor. You know, your S meter goes to S9 plus 60. So this is louder than the loudest signal you could see. We needed some sort of bandpass filtering to like notch that 888 megahertz signal, which is right below 900 megs, out of the receiver's view or purview. So looked at a bunch of different bandpass filters that we had. For those who are hams and have spectrum analyzers and tracking signal generators, you can actually sweep sweep bandpass filters. You can see some specs to the side. But essentially what I'm showing you here is that, you know, you can get some pretty good notch bandpass filters where, you know, outside the 900 meg band range, anything outside that range, you can, you know, help your receiver be a little bit more selective in hearing what frequency it wants to hear. So this filter, $20 off, I think Amazon or Data Alliance, good 40 dB of rejection outside the band of interest that we're using. So really good if you're next to a cell tower. And, you know, $1,000 filter I happen to play with on another radio project, brick wall filter, very narrow, 50, 60 dB down at some points. And then again, after installation, that 70 dB noise gone away. You can see at the bottom now we're not saturated. We can see all sorts of 900 megahertz signals, some mesh, some not. There's a lot of activity on that 900 meg band. Another view from Manassas. What you see on those white yellow blobs to the left in the lower waterfall display, those are attributed to the toll road, license plate readers, cameras, et cetera, that are being put up all along Route 66. So if you're in Manassas, you're dealing with that. Yeah, I wrote a ping bot for those who want to, you know, talk to somebody in the middle of the night, send PING to the long fast chat group. My ping bot running in Python will respond. There's some third-party apps that run under Windows, meshmap, meshing, similar to the web page I showed you, but just for your local node. So who do you see? What are the packets that are received? Nice little graphical user interface. Again, URLs at the bottom of all these slides. Next steps, you know, again, you guys are just getting in, but we're already looking at, you know, decreasing channel utilization. Do we need to go to a different preset? Do we need more higher gain nodes? Do we need higher elevation nodes? How do we fill in the gaps? You know, how do we get ourselves into Vienna? MQTT, it's really an internet backbone. Maybe you can think of it like an Echo link or All-Star link that links repeaters together. MQTT is just a digital channel that you can link nodes together. We use it sparingly. A lot of people use it to connect all the nodes from all over the world. We as Ham said, we're going to use this to get into Culpeper. We're going to get into Bealton. You know, we're going to put one at my place. We're going to link some pods of people into the bigger cluster of mesh that you saw on the map, but we don't want to rely on it. We don't need another internet chat system. You know, how are we going to do more recruiting? We have a groups IO. Are we going to get to be a size where we need to create regional mesh slots where we're starting to get big? You know, what other beacon intervals or, you know, can we optimize? And again, we have a groups IO. We have a signal group. I do WebEx presentations every couple of months to the new guys who come in. How do we keep up the momentum? So in conclusion, a cool science project. It's gaining a lot of traction. It's not going to replace your typical comms. You're not going to go into an Aries situation and use this, but it's good for, I went out to Dayton for the Hamvention, 300 plus nodes. It worked flawlessly. They ran the fastest preset turbo, 20 kilobits per second. It was great. So yeah, small events in small areas can be quite useful. Typical coverage, 1 to 2 miles with the stock antenna. It's a bit DIY, but there's a lot of COTS off the shelf now. You can buy antennas and cables and adapters and things and just get online. Radios 25 to $100 there. Antennas 30 to 150, depending on Omnis or Yagis. External antennas are really important. High altitude nodes are great if you have anybody that up on a mountaintop or in a knoll in your neighborhood. Consider power issues with solar nodes, have the appropriate battery amperage hours. Avoiding long coax runs. All of us hams know if you're on 70 centimeters, you're not running 500 feet of coax up a tower because you'll lose all your power going up the cable. Beware of different connector types, SMA, and what these radios come with. Bandpass filtering, very important, we're finding, for a lot of our nodes that are more into the city. We out here in the sticks, out here in farmland, don't have a lot of RFI interference from cell towers, but you guys probably closer to the city may be dealing with that. Use your SDRs, they are your friends. Again, discussion groups, all the links to our groups IO, Nova Meshtastic. We have a signal group running. The mesh map is here. If you're closer to DC, there's a DC Discord, global mesh, et cetera, et cetera. And there's LoRa satellites out there. So another presentation that I've done, but that's for another day.
Andy, I got something to say to you, and that is thank you. You've taken our craniums and just poured a boatload of the new into it.